Hello everyone, my name is Pravesh and welcome back to my channel. If you have been working with Terraform for a while, you probably notice that as your infrastructure scale, your code seems to look messy and repetitive. But what if I told you there is a better way to organize it? In this video, we'll explore Terraform module, the secret sauce for keeping your Terraform code reusable, scalable, and clean. So grab a cup of coffee and let's get right into it. I have also written down a blog about this on my website, so I'll link it down in the description box for you to check it out. Let's start simple. What exactly is a Terraform module? A Terraform module is a collection of multiple resources that are stacked together. So think of it like a function in a programming language. You write it once and you use it many times whenever you need it. So instead of writing configuration about EC2 instance, security groups, and your VPC for each and every environment, you can wrap them in a Terraform module and call it wherever you need it, whether it is staging, dev, or production environment. Here's the beauty of Terraform module. Your Terraform module works independently. So if you make any improvement in the module, it will be reflected everywhere you have used them. Now you might be wondering, why do we even bother about these Terraform modules? So there are a few big reasons that makes them must have for any serious Terraform setup. First is the principle of reusability, which means write it once and reuse many times. So it eliminates the chaos of copy pasting resources across multiple environments. Second is the principle of scalability. So as your infrastructure scale, you might need to update a configuration, for example, related to a security group port. So you just update the module of the Terraform security group and it will be reflected across all the environment. Last but not the least, principle of team collaboration. So as your DevOps team grows, modules help to enforce best practices and standardize architecture. Most companies have a module of catalog that is given to the DevOps team, which helps them save tons of time. All right. And now with this theory, let's jump into a small practical demonstration in which we'll deploy a static index.html page using Apache 2 on our EC2 instance. So if you scroll down to the blog, you'll see this GitHub wrapper link. Click on it. So this is my Terra project repository. It basically contains most of my projects related to Terraform. What I want you to do is fork it under your own account name and star this repo, clicking here, so that you don't miss any update. So the project, the resources of this project are inside this Terra module directory. I want you to use the git clone command and clone it inside your own local system. I have already done that. So let's go to VS Code. So this is our Terra module directory. So one thing I've noticed that we have a separate directory for a module. So this is the best convention. If you are creating custom module, they have to be inside a single directory. Okay, so if I say you that you have to create an EC2 instance and host a static index.html file, what are the things that come to your mind? Like what are the resources that you have to build? Firstly, you need a VPC in which you'll create a subnet, and inside the subnet you have this EC2 instance, and the EC2 instance will be needing security groups, internet gateway, route table, and many more things. So let's get inside this Terra module. Here we have these three things. So let's go inside VPC first. So inside VPC, we have this main.tf file. So inside the main.tf file for a VPC, firstly, you are creating a VPC. We are declaring the CIDR block inside a variable. So our VPC just need a name that it will be the application name /VPC. Below that, we are creating the subnet. So subnet is using a VPC ID and a CIDR range, and we are mapping IP on launch to true because we want it to be a public subnet. We are giving it a name defined in our variable. After that, we are creating an internet gateway so that our instance can get internet access, and we are using a route table to route the traffic from our internet gateway to our instance. And at last, we are having an association with our subnet ID and the route table. So in the output, we are just giving the VPC ID and the subnet ID, and here we are defining the variable. Now that we are not giving any default value, we are just giving variable names. The value will be decided in the main.tf file, which will create while we use this module. Okay, so these are the three variables, which are the app name, VPC CIDR, and the subnet CIDR. So once the VPC and its subcomponents are built, we will move to security groups. So we just need a single security group for it, and we are creating this AWS security group name. The resource name would be web, and the security group name be the app name / web security group. We will have 3 rules, 2 ingresses and 1 egress, which means we have 2 inbound rule on port 80 on which our website will be serving, because it's an Apache static website, and we'll have port 22 open in case if any error occurs, so that we can SSH into the instance and see if things go where things go wrong. And at last we are just opening outbound traffic to all CIDR range. Okay, so in the output we are just giving the security group ID, and in the variable we are setting the app name and the VPC ID. Okay, so once the security group and the VPC are done, we are just left to create the EC2 instance. So this was one of the trickiest part, because I was not able to figure out this error related to this particular command. So we'll get into it. So firstly, we are just getting an Ubuntu AMI. So this is like the boilerplate code which you can get from Terraform official doc. And then we are creating this EC2 instance. So firstly, we are using the AMI ID. We are defining the instance type in the variable. Let's open it side by side. So the instance type would be default as T2 micro, and the subnet ID will be selected from the variable, and the VPC security group ID will be selected from the variable. And this is the main heart of the program. So firstly, we'll update the system, then we'll install Apache 2, enable it, and start the service. And this command particularly gave me many headaches, because I was able to showcase the index.html, but it was not reflecting in the actual EC2 instance. So after very much configuring, debugging, I get to know that this would be the EOT command will be the one that will solve it. So at last we are giving the name to the instance as application name / instance. And here is our index.html file. It basically my portfolio. It has some details that which I have been doing for the I am a DevOps engineer, AWS community builder, open source enthusiast. These are some of my projects, basically achievements, and these are my social link. So that's with the code, and now let's try to run it. Before running that, let me show how we used it. So firstly, we defined the provider. So the provider will be AWS, and the region is US East 1. Now see, we are just defining the module VPC. So we first use the module name, give it a name, and this is the main part. Here we define the source, which is modules. Inside we have this VPC, so it is referring to this module particularly. And in that we have mentioned that we are using 2 variables, which is VPC CIDR and the subnet CIDR. So here is the VPC CIDR and the subnet CIDR, and the app name we are still using variables. So let me just show you that. So the application name will be Pravesh portfolio, and below that, this is our security group. Here we define the source from this main.tf file. It's module / security group. It is referring to this main.tf file. And at last, we are defining our EC2 module. The source is defined as it, the instance type, subnet ID, and the security group. And at last, we are specifying just the variable name. So now let's initialize this Terraform thing. Terraform init. So one thing you have noticed that here we are also initializing the module, which are our local modules. So our Terraform is initialized successfully. Let's just run Terraform apply command, because I know that only 7 resources will be created. So I'll show you that also. So here you can see that 7 modules are created. So let's go it one by one. Firstly, we have this EC2 instance. The AMI ID is taken from the data variable. This is the user data, index.html file particularly. After that, we are defining the security groups. We are having 2 rules. The ingress rule, which will be on port 80 and 22 also, and the egress rule to every port. After that, we have this internet gateway, route table, their association, a public subnet, and at last we have this VPC. So let's just wait for it to come up and running. So our resources are up, and it has the public IP. So in theory, if I go to this address, our static index.html page will be serving on it. So I just gave it 1 to 2 minutes so that the the Apache server is like configured and has routed the index.html file. So let's just copy it, paste, and here you can see that we have a lovely and attractive index.html file displayed on our EC2 instance. So once you have done that, you can just go to Terraform to delete the resources so that you don't incur unnecessary charges. So just use Terraform destroy after you have done it successfully. In case you get any errors, go to your AWS console, and inside the EC2 dashboard we have our instance running. So click on it. We'll connect with the instance using EC2 connect. So one of the probable cause that can hamper your instance from running is any error inside the user data script. So you can get the log of the user data script inside the var log directory. You just need to catch a log that is in cloud init output directory. So these are the log related to your user data script. So firstly, we are updating the system, installing Apache, and just like copy pasting the index.html file. So if any error occurred, it will be shown here. So I hope that you don't get any error. So after you have done with the project, you simply just delete the resources using this Terraform destroy command. So I think this practical demonstration helped you understand how we work with Terraform module. So before you start modelizing your Terraform code, here are some best practices that you should keep in mind. Firstly, you should keep your module focused and meaningful, and most importantly, inside a single directory. Secondly, use a meaningful variable name. No ABCs and XYZ variable name should be used inside production environment. You need to add a version control, because having a version control with Git or like a private or public registry of ## is helpful for getting an update version of your modules. And last but not the least, we used to store this module inside a private or public repository if you're working in team. So these small things can make a big difference as your infrastructure goes. And that's a wrap. Terraform module aren't just about writing less code, they're about building scalable, secure, and maintainable infrastructure. If you like this video, make sure to check out my detailed blog post where I share step-by-step guide including instruction and references. Don't forget to like this video, share it among your network, and subscribe to my YouTube channel for more AWS, DevOps, and Terraform related concepts. Drop your feedback or question in the comment section. I would love to check it out. Also, you can connect with me on my LinkedIn, Twitter, and website. Again, thanks for watching. I'll see you next one. Adios.